You have the container platform. The Vault code is a Docker running on that platform. It will connect to a partition to do all the attestation signature and timestamp stuff. And within that, it runs the customer logic jar. So yes, that's the Docker, and the Docker runs a JVM that runs the jar. And you have the input as a request, and it will use the HSM to do the attestation, and the response is output and signature and all the attestation. What can you do with that? So we talked about automated approval, but the Vault code is also useful as a standalone product. So you have some processes where you have a checklist and you have some input to fill it all out, and you have a person that needs to sign. So you have an archive to have a traceability of the input was verified, and maybe you have a decision as an output. Yes, that process is valid, someone is onboarded or whatever. And more or less what we wanted to do with Vault code is to replace that system with the code. So you would have the checklist is in your jar, which every checklist you have in your company could be automated with a script. The manual signature would be a digital signature from our machine, and you can then archive the result with the signature to say that is what has been executed, this form has been filled out, and that's the decision. So what we actually get in detail out of the Vault code is you get a reference to the input, a reference of the execution code, the output, the timestamp, when it was executed, and platform state and all that. So you can archive that to actually automate some decision making that you normally would do with a form by hand. That was the general idea of the Vault code. There are so many forms in the world where still people do it manually. We want to automate that. I hope there are no auditors in the room, because most auditors fill out a checklist. My long-term dream is an audit is then filled out by an execution code, because you should automate the audit. That's why I said last year in the SCDC that with key attestation, you have machine verifiable proof that the key is in the HSM. So the audit ceremony of the key is in the HSM should be automated as well, because someone is just verifying a checklist, verifying the input, and you need a sign off that that actually happens. So the main idea was any checklist in the world that's annoying, script that. If you need a signature on that form, we have a Vault code that gives you attestation. I hope that's clear. But then, of course, automated approval is also a decision making, right? You need a signature, and instead of the mobile app, your code will be making the decision. So you have as input the TSB approval task. So we fully integrated the both APIs. You don't have to do that by hand. Of course, you could do the Vault code API, address it individually, but since we already combined the two, you don't have to. So it will receive the approval task, and your policy engine is a checklist making decisions. So in Mark's example, the checklist is it below 0.00 Bitcoin? Yes, but that's just an example. Then it will sign the output. So the output of the execution has to be the approval to be signed. The Vault code then signs the output, which then be the approval signature, which then be verified within the HSM when it does the signing request, and it verifies if the SCAR policy is fulfilled. everyone who was in the room, thanks to Mark, you know again what the SCAR policy is. That's the access policy when the key can be used. So if you combine that, then you can only use the key in the HSM if your customer policy engine said yes. So how do you do that together? The output private key of the vault code signs the execution output of the jar. So the output public key of the vault code needs to be included in the SCAR policy. So the only thing you need to do is put that public key in there. What you could do, so threshold we talked about, the 0.001 Bitcoin. You could have a whitelist of internal addresses where you can send to or where not. You could analyze the transaction data, if it's NFT or spawning or staking or DeFi or whatever. So you could also say, I want to analyze, is it a PDF or not, or is it whatever. So you can analyze the payload of the actual signing request to say, do I actually want this signing or not? With the stateful execution, you can also count the amount of transactions per day and say I have a daily limit. And each time I approve, I add it to my state. And then at some point you say, no, you reached your daily limit, like on a credit card, and say, enough is enough. With the TSB, we have already years the option to add metadata to the signing request. So your business application can put any additional metadata to this signing request. Could be some input from the Delphi Oracle about forecast, whatever exchange rate, whatever additional information would be useful for your decision making. So I have a demo, but I want one more slide first. What I wanted to mention is we also have an air-gapped HSM if the HSM needs to be completely offline. So what we had to do is to make that transaction security broker standalone. That means it starts up without HSM connection. And then the workflow works still the same. So you can still approve, you can still do automated approval, but then you need to copy-paste the request into your air-gapped room. We made a QR code, or you copy-paste it to a USB stick or whatever. You walk to the cold room, you do a signature, you come back, and you import the signature in your workflow. The nice thing is that business application does not know the difference if it's a cold solution or not, because his sign request with the unsigned transaction and the signature coming back, that API integration is exactly the same. So the business application doesn't need to know if your HSM is offline or not. That's just sideways. Automated approval also works with that. Yes. So I go back to the demo. To demonstrate the automated approval, we created a Bitcoin wallet demonstration. To approve if it's below a certain threshold, and if it's above a certain threshold, then you need manual approval. How that looks like is on the left, you have the connection to the TSB that handles all the approval, and that is also connected to the vault code for the automated approval for the policy engine that does the decision making. Additionally, we are connected to the testnet because we are not sending around real Bitcoins. Before we go to the wallet, I would like you to see what kind of accounts we have. I say accounts, but these are just keys in the HSM. But the public key corresponds to an address in Bitcoin. So you can send funds to this address, to this key,
or with a signature, you can transfer funds from this address away. If I view this key, I can also see that here I have our famous access policy, the SCAR. And you see here that you have a manual and an automated approval. So the automated approval public key here is actually the one from the policy engine. So that's the output key of the vault code. So in the quorum, which is 1, means I need one or the other. That means if the policy engine decides to approve, then that is enough, and I can do an automated approval. If the threshold is too much, then we need a manual approval with a mobile app. And if you want to see that as well, please contact us and we do a mobile app demonstration. So that's the policy on the key. Here we see different approvals, how we onboard our mobile apps. And so I say from which key I want to send transaction from. So I chose Alice, the one I just showed you, that has in the access policy either the manual approval or the automated approval. Now that's the balance, because you need some funds in order to send. And if I choose to only send a little bit, then this will be handled by the policy engine, by the automated approval. Because in that jar of the automated approval, we did the decision making to approve low amounts. So the vault code is very business independent. This is a demonstration of Bitcoin transaction, but it can be used for any other automated approvals, because the chart is done by the customer, and depending on the use case, on the different business decisions, it can make decisions based on different scenarios. So we will say, I want to do a transaction, and even if we have an access policy, the HSM will be able to sign because the vault code approved this message. The approval is verified in the HSM, like all the SCAR access tokens. And then if the HSM is happy with the amount of approvals it got, it will sign the transactions. So it will go through the vault code. The workflow is handled by our TSB, and the transaction is signed by the HSM, and then it will be sent to the test net of Bitcoin. So when the balloons come, that means the transaction has been signed and broadcasted. So that's the end of the demo for automated approval. If you have any other use case where you want to automate your approval of the SCAR policy, please get in contact with us.
Okay, questions?
Does this feature needs as a license, or is it already, we get this as customer?
You need several licenses. So first, for the whole TSB workflow SCAR approval service, you need a license, right? That has been since 5 years ago, because that's an old feature. Mark did a recap, but that's also under a license. Then you will need a license to run the vault container to load the vault code into the HSM, to then connect the two.